brand new car, it's easy to tell how powerful it is. You can look at figures like the time it takes to accelerate to 60 or the top speed. But with computers it's more difficult. One way of measuring the power of a computer is with the so-called benchmarks, such as those published by PCW magazine. So, John Colt, what are benchmarks?
Well, benchmarks are just computer programs, like this one, which you can run on a range of different computers. This one's just a few lines of basic. It's a basic benchmark. And all it does is print an S, set K to 0, add 1 to K, and if K is less than 1,000, then it goes round again. So quite
it's
simple.
Just counting to 1,000, in fact. But I noticed straight away that you could easily speed that up. For example, these could be integer variables, you could lose the go-to, you could put multiple commands on one line and so on.
Well, put the go-to in, especially for you, of course.
Oh, thank you.
Yeah, but the point is, if you change the program and optimise it for each computer, we'd really be testing your ability to write a good program. And we don't want to test that. What we want to do is to test how well the computer works. So we use exactly the same program, with all its deficiencies, as you rightly say, on all the machines. That way we compare the machines, not you.
So it's a shoddy program. Who wrote it?
Thanks. Well, I put these benchmarks together back in '77. Actually, I pinched most of them from another magazine.
It all comes out now.
Anyway, yes.
So you did all those PCW benchmarks, or you collected them?
Yes.
Right. Well, let's see this one in all its glory running.
Right, I have a stopwatch here. If I can hold it very still and type run and start the watch together, we'll see how long this one takes. Wait for the E stop, and that's about 2.7 seconds.
Right. Now, first question, obviously, why are you using a stopwatch when there's an internal clock?
Well, there's an internal clock on this machine, but there isn't on other machines, and particularly when we wrote this thing, there weren't internal clocks on any of them. If you want the program to run on all the machines, you can't afford to use a clock. So this program, as is, will run on lots of machines.
But the stopwatch isn't terribly accurate, is it?
Certainly not the way I did it just then, no. But no, it isn't. But actually, if you're timing... This one's only 2.7 and the stopwatch isn't very good. Normally, you're timing longer things and it's OK. But even with this one, if you run it 3 or 4 times, it's OK.
So there are many other benchmarks?
Yes, there are. I've got a more complicated one here. Another one in the series, benchmark 7. This has got some of the same elements. K equals 0. From the old program, and if K is less than 1,000, that's from the previous program. But there are other lines in, like this one here, dim M5, that's dimensioning an array. There's some really wild arithmetic here. A equals K divided by 2 times 3 plus 4 minus 5. You know,
higher mathematics.
Pretty stretching stuff. And a go sub here, go sub 230, which just does a return.
All the usual things you might want to do in BASIC.
Right.
I see. But of course, there's nothing like the procedures that are exclusively BBC Micro.
Exactly.
I do notice this, though. This is BBC Basic, isn't it? Colour 129, well, sound 1, minus 15.
The producer, God bless him, insisted that we put that in, turn the screen red. So we've got a specific line in each of these machines. Now, we've actually got 4 machines here. At the far end, we've got a Commodore Amiga with a program in. We've got a Sinclair Spectrum Plus, and we've got an Atari 520 ST, and here we've got a BBC Master System. They've all got the same program in. We'd like to run them. I think if we get Leslie, come on in on that one, please, and Mac on the Spectrum.
Should point out that's a Spectrum 128, not the Spectrum Plus. There is a difference. OK, are we ready? 3.
No.
We're not.
No. Yes, I am now.
3, 2, 1, go.
Right.
Now, mine hasn't run. My function key has collapsed on me, which just goes to prove it is live. Now, at the moment, we've got 4 different micros. They've got 4 different processors. Obviously, we're going to get quite a span.
Amiga's gone. Amiga's gone.
How long was that?
And it was 14 seconds, Fred.
Right. Well, I happen to know that this one would have been, if I got it right, it would have been 17 seconds.
And in rehearsals, this one did it in 21 and a squirt seconds as well.
What's it done now?
22.
Right. OK. So what about you, Mac? How are you getting
Spectrum, very reliably, calculating it on very deliberately. It's going to win in the end.
In the end. Right. Excellent. So, look, why did the Amiga win? Was that because it's a 16-bit?
Well, the benchmark tests various things. Yes, it's 16-bit, but really what it tests is how good the basic interpreter is, or that's another factor. And in many ways, that's testing how good the programmer was who wrote the basic interpreter.
Right.
So it's really testing several factors.
But there's a whole lot of things it's not testing at all.
Exactly. Now, the dear old Spectrum is a bit slow on this benchmark, but it's got some darn good graphics, and you get some assembly language games, which are first rate. So it doesn't test the graphics, it doesn't test the disk drives, how good the keyboard is, what the value for money is. All those things are missed out on this benchmark. You've got other benchmarks for those things.
Of course, it would be possible to put it together on micro.
There goes the Spectrum.
Excellent.
77 seconds. Reliably, I might assure you.
Right. Well, actually, that is a bit faster. That we're actually operating that in 48K mode, because we discovered earlier today that if you run that in in 128 mode, it takes, I think, 107 seconds, which is about 30-odd% slower than that. Very strange. It would be possible, wouldn't it, to put together a micro which just performed well on benchmarks and nothing else?
Yes, it wouldn't be much good for that. The other thing you can do is to choose your benchmarks very carefully by each machine. So when you're promoting a particular machine, you show off the benchmarks that it works very well at. And that's something we see repeatedly in the magazines, of course.
So does that mean we're not really to take them too seriously?
Yes, very much so. Just one more factor, to consider, but don't take them too seriously.
So which of all the benchmarks is the best one?
Well, Max said to me during rehearsals, very good advice. It's really to run the program that you actually want to run in real life. That's the best benchmark on the whole thing.
Right. Thank you very much, John. Benchmarks, just a rule of thumb.